Hey guys, and welcome to another Factorio Workshop. As always, I am joined by MadZuri.
Greetings.
And today, we are going over a smelter design actually built by Zuri. He built it pretty much specifically for our 015 simulation map because this design is extremely UPS friendly and also, just really efficient in general, but yet still produces a pretty high amount of plate. This one's copper, but obviously you could do iron, and it's actually very easy to switch it, which we'll explain as we go over the build here. There's some smart stuff going on in multiple stages, which makes this just a really nice kind of easy to switch around and smart build. So I'll let Zuri go over the smart stuff and anything else that he wants to cover.
Okay, doke. Well, I'll start over here with the set conditions. So we have this set for copper. So requesting about 100 copper ore, which is the number of ore it tries to keep in all the requester chests for the smelters. And 400 copper plate, which is the number of copper plates it tries to keep in all the requester chests for the train station.
Right.
And all the boxes are hard limited to prevent uh, extra calculations from the inserters, if that makes any sense. As opposed to wiring up each and every inserter, they're set very stupidly, I guess you could say. So the boxes are limited, and that's what prevents, or that's what controls the logistic flow.
Right. And it's better for UPS than wiring all these inserters individually and having them do all their calculations.
Yeah, an inserter that's wired, I don't think ever enters sleep mode. But inserters that have their box filled or can't pull out of a or place into a furnace because the furnace is full or busy, then it sleeps, and that reduces UPS drain.
Yeah.
But these are infinite chests or infinite wagon, so these are kind of completely filled provider chests. Normally, you wouldn't have this happen. That's what this circuit's for. It controls whether or not a train can enter, which is another logistic control.
Mm-hmm.
So it's again set for general case where whatever's in this station is added up and changed to signal one, and it's the same one with this bottom station.
Right.
And you can change these numbers. It's set to, I think, 2 and 4 trains worth.
Mm-hmm.
So if it drops below 2 trains worth of ore in the system, it'll allow trains in. And if it goes above 4, it turns it off and it just toggles back and forth.
Yeah. And
And those control this signal, which adds 1,500 to the path length penalty for train seeking this station. So that's the max distance you can build a stacker for one of these.
Mm-hmm. So, yeah, once these turn red, then a train will, it means this has enough ore, and a train will seek out a different station.
Yes, and that's like 3 kilometers in game. That's a huge distance that this one signal will allow trains to repath.
Mm-hmm. Right. So yeah, that covers the smart stuff. It's really pretty straightforward, but works very well. Again, this is what we're using in our 015 map, and we have like 12 or 14 of these, and in terms of UPS and performance, they're incredibly efficient. And this design does 22,000 plate a minute from about 18.3 thousand ore, because of course we have productivity in the furnaces. But yeah, so 22,000 ore or 22,000 plate is not bad at all. And like I said, it's easy to change. If you wanted to do this for iron, all you would need to do really is go into these constant combinators, change the request to iron ore and iron plate, and it would change all the required chests. And then this, I don't even think you would need to change because it's a general thing, right?
Yeah, you don't need to change this unless you're using something with a different stack size.
Right. That's a good point. Yeah. But yeah. So there's that, and it's the what we call, I believe the 8 to 8, right? So each furnace is covered by 8 beacons, and every beacon hits, or I forget the explanation. I just like totally
Yeah,
mix it up.
you had it right. You had it right. It's 8 beacons per smelter and 8
Right.
smelters per beacon
Yeah.
with the
Okay.
extra beacons on the side.
Yeah, that's what confused me was these ones on the outside. I was like, wait, these don't hit 8, but yeah, the ones in the middle do.
Yeah, and you can stack them vertically as well. Though I've learned that that's probably a bad idea. We didn't leave enough room for rails between the smelters, and we probably should have.
Right. Yeah, that's true. But yeah. So this is what we have. Just another thing to cover, right? Is we have these rubber ports in the middle. So this is one smelter, top and bottom, even though it may look like two. This is one smelter in one logistics network, and the difference between doing this and having the stations on the outside and like roboports on the outside on the top and bottom, this is actually more UPS friendly, I believe, to have it this way rather than top and bottom.
Yeah, the bots don't have to cross, I guess, from edge to edge. Most of the
Right.
box can stay relatively near the middle, and only the bots going to the very edge smelters need to travel that far out.
Mm-hmm.
Also, I designed it specifically so that the logistic network ends about halfway through this smelter, so that you can stack the beacons from one build to the other. So you can make these beacon usage more efficient.
Yeah, that's a very good point too. Yeah, this does tile quite nicely.
Which, as we learned, may not be the best idea because you need more room for tracks. But yeah, it can tile.
Yeah, yeah. I mean, you could redesign it how you want. Really, I'm trying to think. I think that's about it to cover. Oh yeah, the inserters.
Oh yeah, to save a little more on UPS, if you use stack inserters, they will sleep a little more than fast inserters. So it's pretty small, and the power increase from using those wasn't as big as I thought it would be. So it's you can use stack inserters here if you're prepared to increase the cost of the inserters, but slightly improve UPS performance.
Yeah. Yep. So you can switch them out if you want. Fast inserters do, of course, work. They're still plenty fast enough, but you do have the option of doing stack inserters for a bit of benefit and a little bit extra power draw and actual resource investment since they are more expensive. But at this stage, I don't think that really matter.
Yeah, assuming you can build this many productivity modules, a couple stack inserters ain't gonna hurt.
Yeah, exactly. So yeah, and just I guess in case you didn't notice, we have the inputs to inputs coming from one direction, and the output, meaning the plate train, coming from a different direction, and it's 2-to-1 because plates stack twice as high as ore, so you need two inputs to the one output.
Train balance, just as important as belt balance.
Yeah, exactly. Nicely said. So I think that'll do it, unless you have anything else to add here.
Nope, that's about it.
All right, awesome, guys. Well, we will put the blueprint in the description minus the cheaty power source because that'll mess things up. But we'll stick this in the description if you want to play around with it. Very good, smart, UPS-friendly, efficient smelter here. And yeah, any thoughts, comments, or anything, submissions as well would be great down in the comments. But until next time, we will catch you later.
Later.